the Earth were a sphere, isn't this exactly what would happen?
No, because there's another.
Yes, it is. What are you talking about?
Hold on. So we've had other observations where the horizon on 1 3/4.
So you're not answering my question, and now I'm muting you. This is exactly what would happen if Earth were curved. That one's farther away, so it's lower in elevation, and the curvature of the Earth is obscuring the bottom half of it. So I need you to tell me, I need you to actually just admit, yes, if Earth were a sphere, that is exactly what you would see.
Are you begging me to admit that? So that's a 12-mile observation. Do you understand what the curvature calculator should be based on that? First of all,
the question is, if something is farther away than something else, then won't the bottom of it be obscured by the curvature of the Earth?
So
that's a yes or no question.
That's a yes or no question, but you're begging me to... Okay, so what's the observer...
Please, Daddy, will you do this for me? Huh? Will you please? I'm literally begging you. Will you please? Will you tell me that the curvature...
You're intelligent, man. Come on.
So, yes or no, if something is farther away, won't the bottom of it be obscured by the curvature of the Earth?
Since you're using that picture as evidence, what's the observer height? What's the atmospheric conditions? What's the heat? What's the temperature? And what's the exact distance to the furthest fucking platform? Simple.
If an object is farther away...
How intelligent you are.
If one object is farther away than another object, then won't the
concept? But you can also explain that with convergence, and I can show you and demonstrate how convergence of perspective works. Right? Simple shit. Oh, windmills? You're going to the fucking windmills? Look up John Dee's windmills. 13-mile observation debunks the curvature. You're just going to show me a picture of what appears to be a windmill far away,
really close,
and not tell me any of the distance. It's nonsense, man. What about the Cavendish experiment? 8 miles should show a substantial amount of curvature, shows a flat plane level.
The Cavendish experiment has nothing to do with 8 miles.
What's that? Fucking sorry, buddy.
So, my question is, and I'm literally begging you to answer this question. Wouldn't the windmills that are farther away have the bottoms of them obscured by the curvature of the Earth?
Yeah, I'll explain what's going on. First of all, can we agree that the bottom of those are all distorted? Would you say?
You can't see the bottom.
But would you say that the bottoms are being distorted, first of all? Are you going to agree with that point?
Portions of them, yes, but the bottom of the I don't know what you call that. It's not a mass. I don't know. You can't see it.
Okay.
Look at that. The propellers, it's like half of the propeller. And then, yes, there's this little mirage effect.
Warping from distortion, right? Back there. Okay, so what I can clearly see is the front have a certain amount of atmosphere, and the ones much further away are looking through much more atmosphere. And we know that refraction happens through dense medium, right? So we can already establish that. Logically, we can just establish that. Now let's get to perspective, right? Convergence?
Yeah, the curve of the Earth obscures the bottom half. That's the perspective.
Can we establish what that distance is?
In this photo? I don't know. I didn't take this photo.
Then why are we using it for a talking point, bro?
Because it's evidence.
Okay, well, I can show you an actual video where we can show those same windmills, right? John Dee's video, where he goes and shows the horizon well beyond 13 miles with the boat showing well beyond the horizon in between these. And it's a video, right? We shouldn't be looking up a single photograph, because some of the videos...
Why does this happen?
Would you say the tops, I can clearly see that it's not a perfect sphere. Is it being distorted in any way?
Why is the bottom of it being obscured by this line here?
Why?
Yep.
convergence and something going further away.
No, convergence is not when something goes underneath of something.
Does it not happen in observable reality? If you were to stand under a light pole and then walk,
The sun does not get smaller as it gets farther away.
It does, and I've got.
It
five
does
different
not.
videos. So if anyone's recording this video,
I am.
please send me this, please, brother, and I'll show you 5 different videos proving you wrong on that with solar filters, like you guys all claim, and we count.
And I can
pixels.
show you solar
Okay.
filters where they prove that it stays the same
fair
size.
enough. We can do this back and forth, but we don't need
Right.
to do this. You're
Why?
just telling me no, you can't.
Why is the bottom of the sun disappearing below the horizon?
Okay, so as something moves away, right, it begins to converge. Would you agree?
That's not what convergence is. Convergence means it gets
absolutely is.
smaller. No.
Absolutely.
The sun
So would you humor me
Sorry.
for a second?
No. Convergence is when something does this as it gets farther away. According to you, the sun is above the ocean, so it will always be above. Now, the distance between the sun and the horizon will always shrink, but they will never actually converge, and they certainly will never overlap. This is a physical impossibility unless we have a curved surface obscuring the bottom of the sun.
Okay, can you put up my
Tell you
picture?
what, I know you're literally begging me right now to change the subject. So I'm going to change the subject, and I'm going to actually change my guest, and I'm going to change my pants too, because that was a really juicy one.